What causes accumulated error in long robot kinematic chains? Imagine trying to follow a winding trail through a forest, where each step slightly shifts your position. Over many steps, small miscalculations can add up to a big deviation. That's similar to what happens in long robot kinematic chains. Every joint and link in a robot arm adds a tiny error that can build up as the robot moves. These errors mainly come from inaccuracies in sensors like encoders, which measure how much a joint has turned or moved. These sensors are not perfect. They can have noise, resolution limits, or calibration issues that cause small mistakes in reading joint positions. When the control system uses these readings to figure out where the robot's end effector is, any tiny error in a joint measurement affects the entire calculation. Because the kinematic chain is sequential, errors from one joint influence the next, and so on, making the final position less accurate. This process is called error propagation. Mechanical factors also play a role. Manufacturing tolerances mean that links and joints are not exactly the sizes or alignments specified in the design. Over time, wear and thermal expansion can change these dimensions slightly, adding more error. Zeroing or homing errors happen when the robot's initial position isn't perfectly set, creating a baseline offset that affects all subsequent movements. From a control system point of view, these errors include inaccuracies in sensors and actuators, as well as imperfections in the mathematical models used to predict movement. External forces or payloads can also influence accuracy, but they are less related to the length of the chain. In real-world applications, these errors limit how precisely a robot can perform tasks like assembly or machining. Engineers address this by calibrating sensors regularly, using sensor fusion techniques to combine data from multiple sources and applying real-time error correction algorithms. External measurement devices like laser trackers can also help correct the robot's position during operation. To sum up, the main causes of accumulated error in long robot kinematic chains are small inaccuracies in joint sensors, mechanical imperfections, baseline offsets from initial setup, and the way errors build up through the chain's calculations. Improving sensor accuracy, refining models, and applying correction methods are key ways to reduce these errors and keep robots working accurately.